audio test. There you go. And we'll just wait until Victoria is ready to go. And we'll hop right into it. In the meantime, here, make sure that it's in there. All right, so we're just waiting up on Victoria. Oh, Terrence is typing. Nice. Y'all should not see anything on the screen other than just me right now, because I have unplugged my laptop. Video and audio are working. Awesome. And we're just gonna get cloned. All right. Howdy do, everyone. How's your day going? Super. Good stuff. Anybody have a particularly filling breakfast? Anyone here a fan of oatmeal in the morning? Yeah. Nice. Who does the steel cut oats? Hey, there we go. These are true oatmeal fans. Steel cut is the only way to go. Oh no, ugh, microwave? What are you talking about? These are artisanal steel cut oats. I got my whole family into steel cut oats in late high school. It may not look like it, but I was very into fitness and lifting, and everyone on the internet was like, oh, if you want to get big, you gotta first of all drink a gallon of milk a day. Like, all right. So there's the gallon of milk a day. There's brown rice and chicken, and then for breakfast, you gotta have many eggs, just many, and steel cut oats. And the thing about steel cut oats is that it takes quite a while to make them. You gotta make them the night before, or you know, I would make them like Sunday evening, and I just put on some music, and you stir. It takes a while, and then you have delicious steel cut oats for the rest of the week. Problem is, got my family into it, so I would make quite a big batch of steel cut oats, and usually by Tuesday, my dad would have finished it all. So just a peek into my life. Is Nima stalling? Is Nima killing time? No. What's up? This is El Lecturino here. We're gonna go CD into the particular thing that we're gonna do today. I'm gonna make a new file. Oh, this one's gonna be called lecture. I was gonna call it lecture.md, but I've already got one. And then I said notes, readme. I've got those too. So let me just hold. Let me just start entirely from scratch here. Okay. So today is it's a neat day. It's a pretty weird day. Yesterday you did async stuff, and I had told you that you would eventually see async for its real purpose. We will now see async for its real purpose. That's what we're going to explore today. Specifically, it being week 2, day 3. What's the point of today's lecture? What's today's concept? TCP, IP, and just networking. So quick, hot networking tips from Nima. That's what this is going to be. So today's whole lecture is about networking. Tip number 1, firm handshake. That is number 1, firm handshake. Number 2, state your name. Right? State your name. Usually at the beginning of some rap songs, they might say, state your name. And you're like, it's your boy, DJ Nima, and all that. So that's handshake, introduction, and then 3, say why you're there. Right? What do you offer to this particular person that you're networking with? here's another tip. Talk out of turn. If you really want to make an impression on people, just interrupt. Interrupt, maybe change the subject. Make it all about yourself. So immediately, the crowd murmurs and goes, "Oh, what? That's not a good tip. Is Nima not the networking guru that we were led to believe? I thought this was Tony Robbins. Is that the dude? Tony Robbins, yeah." They're like, "No, this doesn't make any sense." Exactly. This talk out of turn thing here doesn't really fit the protocol of human networking. We're going to explore networking between machines. Tends to be very similar to networking between people. And just like I said yesterday, that like a big part of being a programmer is being empathetic and really thinking about your computer. Networking is going to be not just being empathetic towards your machine, but being empathetic towards everyone else's machine, right? You know, thinking about how would I want to communicate, and programming is really about taking those like human things and then codifying them, right? Writing them down. So before we even dive into any of the heavy, wait, I was just gonna say don't do this. Before we dive into any of the heavy technical stuff, I want to make it really clear that like sometimes coding doesn't feel like it makes a lot of sense. Sometimes like tech just feels really weird, or especially when I throw things at you like these new protocols that we'll be talking about. Okay? I'm gonna throw a bunch of words at you. HTTP, what? TCP, give me another one. WebSockets, give me another one. TCP, IP. Yeah, what? So many. You want another one? Telnet. All right. Look at all these different things, and it can feel confusing if you feel like it's just alphabet soup. But with each one of these things you're going to learn, not just today, but over the course of the boot camp, I find that the most efficient way to really understand is to put yourself in the shoes of why this thing exists. Right? Like, why did somebody have to come up with this in the first place? And you'll see what I mean as we talk about each of these. So we're talking about networking. In tech. So when I say the word networking, what does that mean? What does that mean to you? Mm-hmm. Yeah, communicating with other machines or people, right? So specifically, these aren't just thoughts that happen in my head. These aren't just actions that I need to tell myself, right? These are actions that need to be told to somebody else, right? And how does that communication happen, right? What are some methods for communication that you know of right now? Between computers. We could even expand it to just between people or between agents. How does communication tend to happen? You use your ears, you use your mouth, right? You might use your eyes. You can communicate a lot with your eyes. Like, check this out. Right? Look at that. So much communication. Very little information, just lots of fear. Right? I could turn it around. Victoria, what? There you go. Just making eye contact right at you. It doesn't happen very often, does it? So all kinds of communication might not be strictly verbal, right? Some of it might be contextual, right? So let me write that down. You're saying you can use your ears, your mouth, right? I'm going to say that this is probably for emitting communication, right? Mouth often for receiving communication. Not very often that you talk to someone and you see them just kind of like, just kind of gulping in your words. Your ears, your mouth, and then there's other things such as like maybe the location that we're in, right? The location that we're in gives some context to the communication. It makes total sense for me right now to be up here and start talking about tech. But if I was at the grocery store, Or if you're like at the club and you're just like, "Boons, boons, boons." Hey, you like HTTP? Like, doesn't really. But has anyone ever told you about what closures are in JavaScript? Doesn't make a lot of sense, right? So the context in communication is a big thing. And I want you to think of all of these things that are, again, human things. So context through the location that we're in. Human things and translate them over to the computer world. Right? So ears, mouth, so we might emit, we might receive. Context gives us some extra information. And then there's a whole load of other stuff, such as like, who am I communicating with? Right. Now, I want us to also think a little bit about medium, right? If we're talking about ears and mouth being like avenues for communication, the medium might be like sound, like air. That's what we're using to transmit information, right? So air could totally be a medium and have information pass through there. What other media are there? Terrence is writing here. Are you in Vancouver? Any ideas for media? You can do a Terrence? A phone, sure. Let's see. Come on, Terrence. Very confused with your ears, mouth statements. Are they bad? Now I'm confused. Did I get something about that wrong? Oh, ears. So receiving and emitting. Yes. Thank you for that, Terrence. Pair programming. That's what this is. I told you about my restaurant idea yesterday. I have multiple business ideas. One of them, I'll let you in on this. If anyone has some money to donate, I'm thinking we take pair programming to the max. Sort of like live. You know how there's like people who stream on Twitch for like playing games. This was a service, like a plugin you install into VS Code, and just hundreds of people are just watching you code, and they're just berating you as you code. So come talk to me later. I've got just a whole spec for how I want it to be built. Anyways, we got mediums. Air could totally be a medium. Your phone, sure. How does the phone work? There's a wire, right? There's communication going through a wire. There's little electrical signals. So I'm gonna change phone over to a wire, right, or some kind of cable. And that's important. Like I do want you to think about the linking between agent A, right, and agent B, who are communicating with each other, and there needs to be something linking them. And it's, yeah. Oh, light, absolutely. Light could also be a medium for communication. I could blink a flashlight at you, Morse code, just optical cables and all that. And at the end of the day, there needs to be some physical kind of connection between these two agents so that they talk to each other. And it might feel a little like banal or silly for me to focus so much on this, but it's very much going to be the crux of the problem for us, is that like we have a wire and we need to stream stuff down there. For a good chunk of today's lecture, I'm going to be using an analogy of the tin can telephone. So I wonder if there's a can emoji. Oh, there is. Beautiful. So I'll be working with the tin can telephone. Is anyone here not familiar with the tin can telephone? Cool. Okay, so I have a can, and I speak into it, and on the other side, somebody listens. How many people can talk into a tin can at the same time? On one end. Let's say like on this end here, how many people can talk into this tin can at a time? Probably one. Probably one. we could maybe figure out, right? And that's what we're going to do is we're going to talk about like maybe rules that we can come up with as a group to all share this one tin can, right? And the same thing goes on over here, like how many people can listen at a time? Probably one, right? But maybe we can come up with some rules to make it possible for multiple people to share the can, right? And so questions that, as soon as we think of a medium, questions that pop up are how many people, right, or agents can be connected? Right? How many people can be connected at a time? Also, how many people can input at a time? Right? How many people can put in information at a time? In this entire system, right, how many people are able to talk at once? 2. Right? And the 2 people who are able to talk at once are on both ends, right? Over here and over here. Does it make sense if they're both talking at the same time? Right? It's physically possible for me to be shouting in a can and for someone else to be shouting in a can, but it doesn't make sense because I'm not going to hear what that person's saying, right? And they're not going to hear what I'm saying. So maybe we need to come up with a protocol, right, that goes beyond the limits of just this physical medium and has some like rules to it that makes us have the ability to use the medium in a meaningful way. And so we're going to start seeing a bit of like a separation of the medium itself and how you use the medium. Right? I'm going to say that these are some immediate questions, but the separation is going to be between the medium itself and how to use the medium. The medium itself will bring like baggage with it. Right? What do you think some of the baggage that comes with a tin can telephone is? You can only go so far, right? You can only go so far, and also I think the string has to, the thing has to be taught, right? So the medium itself has some baggage, right? For example, right, tin can phone can only stretch so far. Right? There's other baggage with it. For example, tin can phone might be pretty fuzzy to listen to. It might not be great. It might be pretty low quality. And what does that mean? If I'm sending low quality messages, the message might be distorted, and the people on the receiving side might have to say, "Hey, can you send that message again? Right? Can you? I didn't hear you. Come again." And these are things that are, again, a consequence of the medium that we've picked, right? So it might be pretty low quality, which means that we might have to send messages more than once, right, to ensure that they get received properly. So what we're seeing here is immediately, by adopting a particular medium, we start having to come up with rules about how you use it. For example, I might want to get confirmation that a message has been received. Right? So say you're using a walkie-talkie, right? Walkie-talkies, like you got to go like 10-4, over, roger, roger, right? There's all kinds of things that you say to communicate to the person on the other side. I've received your message. Right? So how we use the medium comes directly out of the medium itself. Now, I've said that like the analogy of the medium that we're going to use today is this tin can phone, because this relates really, really well to how networking between computers is going to work. Right? We're going to be, for the purposes of today's lecture, be imagining a world where 2 computers are connected with a direct line. Right? That's not the real world. Like, for example, right now, I'm actually not connected to another computer. Right? I am through Wi-Fi, and then that's connected to other stuff. But we're going to be imagining a world where like my machine is directly connected to every machine that I need. So let me think a little bit more about this tin can phone analogy. We come back, so how to use the medium comes out of the issues that the medium itself presents. And then I'm going to go higher order or abstract rules for later. That's just a note for myself. So as we come up with this idea of the tin can phone, what we'll do is we'll make a specification, right? We're going to work through the rules of how to have our tin can phone. So I'm going to go right here. I'm going to say, OK, this is the tin can phone protocol, also known as TCP/IP. Right? This is my own protocol. Y'all seen? Let's see. I think Andy Lindsay did a lecture last week and showed you like RFC something. Is that? Remember seeing the tea brewing protocol? Is that a thing? What lecture was that for? Yeah, ISO. Wait, did you go through the OSI model? Has the word data link layer, have the different layers already been talked about to you? Cool. I just want to make sure that I'm not going over content that like you already know. So let me just check real quick. Yeah, so there's the International Standards Organization. Sweet, and that would have been, was that for callbacks? Oh, for ECMAScript. Okay, cool. Sweet. So just wanted to make sure you have not heard the word OSI before. You've heard ISO. Okay, cool. So OSI is not the same as ISO. Shares similar letters, but this is going to be slightly different. ISO is the International Standards Organization, right? And they're an organization that puts together a list of standards or protocols to follow, right? So for example, the ECMAScript stuff, like that's done by ECMA, but it's a similar thing. Or I think Andy showed you the example of like the tea brewing protocol, stuff like that. We're going to come up with something very similar. Right? I just want to give you an idea of like, we're not implementing anything, we're rather writing out a standard for something. So I might say something like, my tin can phone protocol, the first part to it is like what is it? Right? And I might say, okay, well, this at the physical layer, so physically, what is it physically? Physically, the tin can phone, right, is a pair of tin cans, often tomato sauce, connected by a wire, right? And then you can pick a wire, copper wire or something. This is how we're going to connect these two cans. I don't know if copper wire is going to work great for the tin can phone, but when we come up with the physical description of this thing, and then we get into the how can one use it. And we'll say agent 1 can shout into it while agent 2 is listening, and vice versa. Right? Ideally, there shouldn't be two-way communication simultaneously. Otherwise, we might have clashing messages. Right? If you don't have standardized, okay, well, these two people shouldn't be talking at the same time. But we have to go further. Like, how do we ensure that there aren't both people talking at each other at the same time? What can we do? Right? So something about like implementation of single use speaking. I don't know, single actor. Some implementation of how do we get only one person to talk at a time. Does anyone have any ideas of how we might come up with like only one person talking at a time. Cool. All right. So one idea is maybe have a code word, right, to indicate that you are done talking. Right? And that's great. But what happens when neither of us is talking, right, but then both of us arrive to talk at the same time? Right? So having a code word is good for say that like you're done, but maybe there should be a code word to also say that you're about to start talking, right? So, you know, an extension of this is also a code word to say that you are about to start talking, right? And maybe you might wait for objections, right? So there might be a, like, I end communication, and that's good. But I might also say, I'm about to start talking, and then I might wait 2 seconds, and unless somebody says, oh, I'm about to start talking too, right, then I'll start communicating, right? And if somebody does clash with me, then maybe we'll just both wait a random amount of time, maybe, right? Like I might just randomly wait 3 seconds or 5 seconds, and then I'll try again, right, until one of us kind of wins. Right? That's maybe one way of structuring this communication. As you can tell, I had a lot of friends in my treehouse, just with all these rules. But you can imagine that with a couple of just printed out rules that we agree on, we could even get this extension working. Right? Here's another one. Here's another idea. As opposed to, like, instead of having a code word to initiate that you're done talking or that you're starting to talk, what if you were only allowed to talk on even numbered minutes? So then there's just, if there's 2 of us and one end can only talk on the even numbered minutes, and the other end can only talk on the odd numbered minutes, then we'll never clash. Okay? We just won't. So I know to always be listening when it's odd, and they know to always be listening when it's even. So another idea could be have like patterns for when you're allowed to communicate. Right? And this is a real thing. It's called time slicing. Right? Time slicing meaning, okay, I have this period of time. You can do what you want with it, or don't use it. That's fine. But it'll continue showing up. Right? What's an issue with this? Yeah, I eliminate how much I can communicate, right? If I say that you're only allowed to talk for a minute, right, then I might not be able to get everything that I want to say out. And what I might have to do is, the minute is up, and then I just wait. I might even say, hey, I'll continue this later. And then I wait for a minute. And then when my minute comes up again, then I continue talking, right? That's something that I could do. I imagine it might be frustrating. And what it also means is, if I have an entire minute, right? Because maybe a minute is not enough, but it's also equally possible that a minute is more than enough. Right? Like maybe all I need to say is yes, and a minute is way more than I need for that. Then I have all this empty space, all this dead time that I'm waiting. And so there's some waste that happens. Again, it's not necessarily due to the medium itself, but it's more due to how we're using this particular medium. Right? So again, at the end of this lecture, and this is similar to what I said yesterday, is you're not going to come away from the lecture feeling like you fully understand how to use these protocols that we're going to be talking about. I want you to have an understanding of where this stuff comes from a motivational point of view. Right? So we could sit here kind of all day coming up with multiple ways of using this particular medium, right? And every way that we come up with is going to have its pros and its cons. Right? You know, one of the pros to time slicing is that I can change the slice of the time. Instead of being a minute, I might say that everybody gets to talk for a second, right? A second, and you can just burst out. And then what we can have is like this interleaved communication where like I might be communicating every second to you, and you might be communicating back every second, and I can both talk to you and listen at the same time. Right? And I think that's pretty interesting. Right? We could do stuff like that. At the moment, are there any questions about this? So one of the things that I encourage you to do, right, is when you do start coding, try to come up with your own protocols for how you might communicate between different things. Right? For example, like I'm going to be starting to talk about, like I said later, is TCP and then HTTP as well. Right? And I again encourage you to come up with your own analogies, or how would you implement this instead of the way that it's been implemented, right? And I find that that's, especially with protocols, a really good way of like wrapping your head around this stuff. So beyond the implementation of simply getting communication back and forth to each other across the wire, there can be sort of like a, what I'll call like a higher order or abstract rule to the way that that communication gets sent. So to put this into kind of maybe more tangible terms, I have the wire, right, or I have the tin can, and I've come up with rules that allow us to talk through the tin can. But the question now is, what are we going to talk about? Right? Should I just be able to talk about anything? Should I just be able to just spew words? Like, oh, this is my minute on the can. Bah! Just for a minute, and next minute, bah! Like that, no, maybe not. And at the same time, like maybe there are questions that usually get asked through the can. Like if these two cans are set up between friends, right? The questions that might come up are, hey, are you free? Right? That might be a question that, in the context of where the can is set up, right, it makes sense to ask that question very often. Here's another question. Can I have some money? Right? Like, just typical, you know, questions that you ask your friends, right? Can I have some money? Are you interested in making money from your own home? Right? Just friendly questions. So the thing is, like most of the time when we have some line of communication between two agents, it's because one of them at least needs something from the other one. Right? There's a context to it. Computers aren't just connected to just like poke each other and be like, hey, you still awake? Yup. Usually there's some information that needs to be transferred between them. So there might be some, like, give me a resource, right? For example, send me an image, right? Or send me some text, right? Or send me the status of some component. Like maybe there's a machine that controls some lights, and I want to ask that machine if this particular light is on or off, or what is the temperature in this room, right? So send me the status of something. So I'm keeping this very vague, right? Because this is more about asking for a particular resource, maybe, than like domain-specific stuff. So we could phrase this stuff in any number of ways. If we were talking about a phone line and we were talking to a person, right? People have the ability of like understanding natural language, so I can phrase things pretty loosely and people will kind of understand, right? And even if people don't immediately understand what you're saying across the line, they have the ability to ask you questions. Unfortunately, machines do not have the ability to just understand things. Right? We have to very explicitly lay stuff out. So there is, a difference between saying, hey, can I have the salt? And, hey, yo, hit that boy up with the salt. Right? Like those are slightly different things. So what I'm going to do is I'm going to pick a particular format and stick to it. Right? So I might go, all right, I like this one a lot. So this one, nah. But from now on, every single piece of communication maybe that happens between the tin can phone, first of all, we've decided that it happens through the wire. We've also decided that people can only talk one at a time. This is how it's going to happen, maybe with the code word method. And then when people talk, they're only allowed to say, hey, yo, hit that boy up with the X, right? That's the way that we're going to talk. And so it's some extra rules on top of the already defined protocol. I could come up with more examples, but I feel like we're getting the gist of this. So at the very least, what we're seeing is some degree of separation between different problems when it comes to networking or when it comes to communication. I haven't even talked necessarily about like receiving messages yet too much, but it's going to be very similar to this. What we're seeing here is, again, to kind of explicitly break it out into Nima's stack, is the physical stuff, right? How are these things actually connected to each other? And then I might call this like transportation of messages, right? How do the messages actually get transported through the stuff, through the physical stuff? And then yet another one, which is what kind of messages can you make? And so I've broken this down into 3 different ideas for myself. And any one of these can change. I could at any point decide, hey, I don't want to be on this wire. I want to be on a different wire, but everything else stays the same, right? I can decide that the way that messages get transported is I'm going to decide it's going to be different. And chances are that that might not change what kind of messages I can make, right? And then on top of that, I can also change what messages I want to make. Right? Some of these things are going to be easier to change than others, but it's nice to see that they're at least sort of separated. Right? So about this idea, our tin can phone protocol, right? Which could get more and more complicated if we wanted to, right? Are there any questions? Can any of you see yourselves using this with your family and friends? I mean, how nuts would it be to like receive a message from a friend, 20-page thing being like, hello, from now on and whenever you want to communicate with me, these are the only words that I will accept, and yada, yada, yada. Kind of nuts between humans, but with computers, it makes a lot of sense. What we're seeing here is this very specific thing called the OSI model, the Open Systems Interconnection model. You can go take a look at it. The OSI model is one way, and it's one conceptual model, meaning it's one way to think about networking. And the OSI model splits networking into 7 layers. The physical layer is very similar to what we were talking about with the wire. There's the data link layer, network layer, transport, session, presentation, application. The deeper you go into networking, the more you see that specific things can be split apart. Right? We're not going to dive into all of these layers. And in fact, as a web developer, you don't need to know all of this stuff, right? But you do need to know that there is this idea of a layer of communication underneath. Right? As a web developer, you're often going to be spending your time up around here, maybe without even knowing it. And we'll explain what these layers kind of mean. The reason this is thought of as layers, right, because the data link layer ends up using the physical stuff. The network layer ends up using, again, whatever data link is. And transport ends up using the network stuff. And this stuff is kind of stacked on top of each other, sort of like pancakes. Now, I do recommend maybe looking up a video or two just to get like a brief understanding of what this stuff is. Do not recommend, personally, spending too much time on this, right? But I do want you to have a general idea of what abstraction means in this context, right? generally, as we get higher up in layer, we get further away from the physical stuff and further away from like tiny details, right, into more general concept stuff. Right? How do you use this thing? So I'm going to take what we've done right now and kind of draw a parallel over to the stuff that you're actually going to use as a web developer. Right? I'm going to go in here, and I'm going to use the words tukapa and ip. So, like I said, computers are screaming just all, I guess I didn't say that, but computers are screaming all the time. They're just shouting into wires. And you can check this. You could go into your, what's it called? There's the activity monitor, right? So there's this thing called the activity monitor. I could go look at the network tab, and they're just shouting at each other. Look at that. Google Chrome helper is, how many packets are you sending right now? Ah, just shouting. System UI server, whatever. I don't know why Spotlight is doing network requests, but it is. Right? And all these various parts of your machine are just yelling all the time. And they're going to be yelling at other machines through something. So usually I do this on the board, but that's not very visible on the camera. So I need some way to have all of these programs on my machine talk with the outside world at the same time. Okay, that's the thing. Like, unfortunately, or not fortunately, fortunately, we don't have to just use a single program at a time on our machines. It would be bananas if you tried to go on Facebook and your computer says, oh, sorry, I can't connect to Facebook right now because you have Twitter open in another tab. That would be rough. Right? So we need some way for our computer to talk outside. So there is this idea of ports, where a port is going to be sort of like a window on your machine that you get to talk through. And not only do you get to talk through that port, you also get to listen through that port. And your machine is going to have many ports, and we're going to explore them today. And so I wanted to put that out right off the bat. We're going to be playing around with ports. And through these ports, you can talk in really any way. The particular way that we're going to be looking at today is going to be called TCP. What does TCP stand for? Sweet. So we've said transmission control protocol. Stands for, I mean, is it transmission control protocol? I always forget. We can look it up. TCP stands for, I thought it was transport. Oh, transmission. Why am I thinking transport control protocol? Looks like I'm wrong. Yeah, huh. All right, so TCP stands for the Transmission Control Protocol. The reason I'm stuck on transport is because TCP lives in the transport layer. The Transmission Control Protocol. And TCP is going to be very similar, or it's going to be analogous for us to the idea of how do we do this? How do we implement the ability to communicate between two agents? So there's, before we dive into any code, as if you needed one more metaphor, I will throw this out here as a metaphor, then we're going to dive into some code, and then we'll come back to it. Right? And the particular metaphor is that there's a relationship between these ideas of TCP, IP, and HTTP. Right? So IP stands for the Internet Protocol. TCP is the Transmission Control Protocol. HTTP stands for You got that, yeah. What was the word that I think it's hypertext transfer protocol. So HTTP stands for, no, not my calendar. Woo. HTTP stands for hypertext transfer protocol. You'll explore this in depth. Like you will get good with HTTP, but not today, and a little bit today. So hypertext transfer protocol. So when we come back from the break, we're going to be working mainly directly in TCP, but I want you to know the relationship between what TCP means, what IP means, and what HTTP means. You can think of IP as basically a highway between computers. And so a highway that connects many computers to each other. And I mean, I have 100 computers, and this is a highway that connects every computer to each other computer. So IP is the highway itself. It's the infrastructure itself. Doesn't mean that IP is the physical thing. It's just in our analogy, it's going to be, in our metaphor, it'll be this highway. And IP still refers to how you use the physical stuff, right? But it's going to be pretty general. It just says you can throw stuff down this highway. Right? What can go on the highway? Right? Well, you can send bicycles on the highway. You can just go walking on the highway if you wanted to. Or you could drive trucks. Right? TCP is one of the things that you can put on the highway. Right? One of many. Right? TCP is one of the things that you can put on the highway, and we're going to be thinking of it as trucks on the highway that are on their way to find a particular computer. Right? Why would a truck be on the highway? Why would it be going from point A to point B? Well, usually because it's trying to transfer something or it's trying to transmit something, right? What kind of stuff might that truck be carrying? Well, it might be carrying, I don't know, feathers, molasses, yo-yos, just typical import-export stuff. One of the things that a truck might be carrying is a website. Right? The HTML for a website, right? Or images for a website, or JavaScript for a website. That stuff can be formatted as HTTP, where HTTP is going to be the load on the trucks, right? Or HTTP is going to be the stuff that you send with TCP. Right? So to take us back to the tin can, TCP is going to be closer to our rules about how you can communicate, right? How are messages sent? Whereas HTTP will be more along the lines of how do you format a message, right? What can you say in a message? Does that sound okay? Cool. So it is 11, and I know we started a little late, and I don't want us to go over time. So we will take a shorter break today. I accidentally gave you a long break yesterday. So no more breaks for the rest of boot camp. But what I do want us to start doing is actually writing a tiny little bit of code. Right? Teeny tiny little bit of code. First question, when we have to write this code. What do I need? I need 2 computers probably, right? So I might need 2 computers. If I'm just going to start on this one here, right? And I want to make a file, right? My initial thing is like, all right, I'm gonna write some code. Let's fire up a file. Cool. What am I going to call this file? I might call it HTTP. Oh, .http. Oh, so you're thinking of the extension. I'll say it's a JavaScript extension. Right? But I really want us to think about what this file is supposed to do. What is this script? I know, again, I haven't given you any context for the code that we're going to write. Right? All I've said is we're going to be playing around with TCP. Right? If I say that TCP is the trucks on the highway, right? It's the trucks on the highway. When we're talking about TCP, we can either dispatch trucks, or we can receive trucks. And I might start off as the dispatcher. Right? So I might go dispatcher. Right? That's what I'm going to do. I go dispatcher.js. Is this a real JavaScript word? Is this a real networking word? No. Right? But I want you to think about the role that this file is going to play. So I'm going to start writing like a script that's going to send messages. Right? And then I might write another script that receives messages. And I want you to see the difference between what's going on with those two. Cool? Cool. So think about this idea a little bit. The words that I'm going to put in your head are client and server. Right? I want you to think about what client and server means to you outside of tech. Right? Outside of boot camp, what do the words client and server mean? So we'll take a break. It is 11:03, unless there are any immediate kind of pressing questions. Neat. OK, so we'll start up again at, let's say, 11:15, just like right on the dot. And we'll continue from there. Cool? Cool, cool. Hey, what's up? Hey, Victoria. Let me know when the audio and video is working for you. Oh, Caitlin. Oh, we got Caitlin Graham all working. Awesome. All right. So we're gonna get right back into it. At the end of the first half of the lecture, we'd written out this big file here. So, no, we hadn't. We're gonna work on that. Boop. The end of the first half of the lecture, I told you to think a little bit about what client and server mean to you. Does anyone have something that you want to share? Yes.
The client receives something. The server provides something.
Cool. So the client receives something, and the server provides something. Client receives something, and the server provides something. So we put ourselves in the shoes of some. Have any of you been clients before? Have any of you been servers before?
Yes.
Cool. Nice. And have any of you been clients before? Right. So usually, when I walk as a client into a place where there are servers, it's not very often that someone will just like immediately like, here is chicken Alfredo. There you go. Like, I didn't ask for this. I never asked to receive this particular thing. This is definitely due to context, though. There are some places where as soon as I walk in, right, I might receive something. Right? Like, I might walk into, I don't know, what's an example of a place where you go in and you immediately receive something from someone? There you go. So if you go to Sephora sometimes, which I do, you receive free makeup. Sure. Actually, it's funny that you bring up Sephora because I was going to use a makeup analogy later. So the client receives something, the server provides something, and just to write this in the notes, the relationship between client and server, there's a contextual relationship between the two. Right? There's a contextual relationship, right? Often the client will often have to ask for something, right? Like the server won't provide, or think again, in real life terms, the server might not provide something until the client asks for it. Hey. There are other cases maybe where a client will provide some, will ask for something. Okay. Let me rephrase that. Most of the time, clients ask for stuff and then they receive it from the server. But there might be some contexts where the client doesn't even need to ask and is able to receive stuff. We're going to start off with the idea that the client and the server are just two people that get to talk to each other. But the server happens to be like a host. Right? We'll say that the server is kind of like the person who owns the place that you're going into. Right? But you're both able to talk to each other freely. So these are by necessity two things. The client and the server are by necessity two different things. I can't have my client and my server be the same person. Then it's like, why are they even communicating with each other? And so I will need, as I'm doing this example, right, I'm going to make two different files. One of them is going to be called, I called it dispatcher, but I will rename it to client. And the other one's going to be called server. Right? Do they need to be called like this? No, I'm just doing it to like be really explicit about what our demo is going to do. So, whoops, not delete, but I'm going to rename dispatcher to client. So to outline what this demo is going to do is I'm going to start just by getting client A to talk to client B, or to agent A to talk to agent B, meaning my client to talk to the server. Okay, that's really all I want to happen. And I'm just going to get them to send a hello world. So maybe my client's going to say hello world, and my server is going to say hello back, okay, just to get started. And then we might add some extra functionality on that in user client and server for something like interesting. So You're going to start off by imagining some dream code. Right? If I said that I want to connect to a server, I want this program here to act as a client. So it should connect to a server and send a message. What would you want this code to look like? Right? So I'll say this out in steps. I want to, I'll do this like this. Right. I want to connect to a server. And Terrence just says sushi and green tea. Did I ask a question about food? Okay. Cool. So I want to connect the server, and I want to send a message to the server. Right? And the message could be something like, hello world. Right? Again, what might we want this code to look like? There's no wrong answers. I have to specify the server that I want to connect to, maybe, right? So I might do something like const server, right? And then I might do something like start a connection to the server, right? So start a connection to a server. So I might give this a name. To the server 1. Right? Maybe it's got a name somewhere. Is this real code? No. Hey, but we're thinking about patterns here right now. And what do I want to do after I have connected to the server? I want to send the hello message. So what might that look like here? Pardon? If there's a connection, right? So maybe if server.connection, equals true or something. Like, again, I'm making this up, right? Just because you said if, so I made it into an if statement. And then I might want to send a message. So how does the send message maybe work in your dream world? Server.send message, right? And then I might put the message in here like hello world. This is fine. Right? This makes sense. I have the server, and then I'm able to send a message to it. Right? Conceptually, I think this makes a lot of sense, but we're going to run into an issue because we're working in JavaScript. Right? So in most languages, you would be right to go by some pattern like this. In most languages, this is going to make sense. Say you're working in Ruby, you're working in Go, if you're working in Python, it'll generally look like this. Like you make the connection, and then you get to send the message. This is going to be slightly different. I'm going to have us change this a tiny bit. And it's not going to be exactly the way that the real code is going to be. You'll see the slight difference in the real code as well. How long does it take to start a connection? You don't know. It takes an indefinite amount of time. The connection doesn't happen immediately. What is the word that we use when we say that something's going to take a certain amount of time? What's that? Indeterminate. Sure, I'm talking about, and you said duration, right? Duration, that's a good word for it, but specifically in programming, right? Asynchronous, right? This is an asynchronous operation. Start the connection. It's not going to happen immediately, right? Whereas this if statement here is going to run immediately after this. So there is a chance that by the time that this code runs here, the connection is not actually ready yet. Right? Does that make sense? The way that this is a JavaScript thing, they have asynchronous operations that will just spin off. And your code will continue running while those asynchronous operations are happening. So the thing is here, the server might not yet be connected. So what happens is server connection might still be false. So I never actually send this message. And then what happens is my program terminates. Right? My program ends. So I need some way of catching this stuff here and making sure that this only happens once the server has connected. Right? Only once it has connected. Right? Especially if I tell you that this thing here is going to be an asynchronous operation. What kind of tool, what kind of language construct can I use to make something like that happen? there we go. And Terrence says a callback. Right? I could use a callback, meaning I might write something like, here is, I'll do this up here. I'll say something like, this is a send message function maybe, or like a function that I've made myself. And this is going to be a function that says, if you give me a server, right? So that's what that says. If you give me a server, then I will go server dot, I'll just say send, right? I just want you to see that this send here and this send message are different. I'm going to rename this one, by the way, to just send. Is that OK with everyone? Again, this is not real code. This is about patterns. But what I might say is, if you give me a server, then I'm going to use that server to send hello world. And now what I'll get to do is, this code here, I don't need to necessarily write this if statement. What I'm going to do is I'm going to say something like, OK, when the server on connect, right? Maybe there's a function that I get to call in the server that says, hey, when you connect, then send message. Right? And notice that I'm not the one who's invoking send message. I'm not doing that. Right? I'm saying to the server, hey, you know what? Here's the send message function, and you can run it when you've connected. Right? It's a switch in thinking. I'm not the one running this. I've inverted the control. Right? Now, I would need to look inside of the server code to find out, is there an onConnect function or something like that? But supposedly, there might be. And then inside of the server itself, somebody would have written something that looked very much like this, right? But would have dealt with the asynchronous nature. Another way that I might write this is the people who've made the start connection function, they may have written this function such that it receives a callback to say, this is what you should do when you've connected, right? That's just another way of doing really the same idea. So the callbacks are mostly going to be useful when you need to attach something to happen when a certain event triggers it. Right? I wanted you to see this outside of the context of the actual code that we're writing, so you can see a little bit of the motivation for why I'm going to have to write my code in a particular way. Does this feel useful to you all? Right? Or is this confusing? Is there anyone who has some, like, because I do want to kind of format this along the way that you feel. Does this make sense? Right. So just to put y'all on the spot, why do I have to write this using callbacks? So you said it's an asynchronous thing, so I have to. Do you want to expand a little bit more on that?
Because you have to wait for the connection to start.
There we go. Right. So for Victoria, it's because, sure, it's an async operation. But what I need to do is I need to wait for the connection to be established before a thing runs. Right. And since I'm unable to wait outside, I give the action, and I trust that the server is going to run it. Right? Or this like server connection is going to run it. So again, we've seen this kind of at a high level. I'm going to jump into actually writing like real code that does this in a minute. Right? So are there any questions about this before I start working with like real TCP code? Neat. So I'm going to make a folder. I'm just going to call this one TCP. TCP demo. And we're going to see all this stuff in here. In my TCP demo, I will make a client.js, and I will make a server.js. Right? And it's in there that I'm going to be working on stuff. So now I have the code just on my phone because it's quite a bit of code. So let me just bring it up. So what I'm going to be doing is I'm going to be using a particular module, and you've learned about modules at this point, correct? Right. I'm going to be using a particular module that is already built into Node. And this module is going to be called net. Right? You can see that the code I write is going to be very similar to that hypothetical code that we came up with together. So, const, let me just make the font a little bit bigger. Const net equals require net. Right? So as you've seen, when I go require, I'm bringing in some code. And I always think it's fun to console.log this stuff and just see what it is. Right? So I'm going to go const net is require net, and I'm going to console log it. So we'll see what happens when I go into my TCP demo and go node client.js. And if I run this, I get a whole mess of stuff out. A whole mess. Net is a particular library that lets me work with internet like connectivity stuff. It's going to let me do all kinds of stuff with TCP. It'll probably also let me do all kinds of stuff with sockets and HTTP and all kinds of stuff that you can explore. You're going to see that net makes you write a lot of code to do very minimal stuff. And so in the future, you're not actually going to be working with net. You're going to be working with stuff that's built on top of net. Right? Today, you're going to be using net. So if I look through net, I notice some interesting things. Specifically, there are some functions, such as create server and create connection. Right? If I'm working on the client side, right, I'm making a client that should connect to a server, which of these do you think I'll use? I might create connection, right? So we're going to create a connection to connect to an existing server. Okay, and that's what we're going to try. So there is this create connection function. I can go, OK, well, here is net.create connection. And net.create connection is going to take a bunch of stuff. I'll just tell you that net.create connection takes an object. And that object is going to have a bunch of configuration in it. Right? You get to say, like, where should I connect? Right? That's what I'm going to write inside of this object. So I'm going to save this potential connection by doing something like const. And I'm going to save this connection as being called client. Right? You can name it anything that you want, but you want to hold on to it. Because I want to do stuff to this client. Right? I want to do stuff to the connection after I've made it. So you go, OK, const client, net, create connection. At the moment, I haven't passed any configuration in. But even this on its own should start doing something. And so I go node client.js, and I run it. And I'm going to notice that there's an error popping up. And which is fine. It means something's actually happening. Let me even get rid of this console log net just so that there's less going on. That up. So when I go node client.js, this is the particular error that I get. What does my error say? What's that? Unhandled error, right? It says there was an unhandled error event. And then what it says here is the specific type of error, and this it's a little terse to read, but you can kind of Google it and find out what this stands for. It says that the address is not available. The address that I'm trying to connect to at the moment, not an address that I can connect to. Part of the problem here is that like I haven't given it an address to connect to. Right? So it's going to, by default, try to connect somewhere. But maybe that place isn't allowing connections at the moment. I'm going to specifically say that I want to connect to a particular machine. And the machine that I want to connect to, I get to call it a host here. I want to connect to myself. This might feel weird, but you can have multiple programs on your computer that talk to each other through networking. So I'm going to have two programs, and they're going to talk to each other through the same IP address. I can find my IP address by going into my Wi-Fi, if I'm on my Mac, open network preferences, and then this takes a second. Where are you at? Oh, it's already here. Oh, there you go. These are my network preferences. Now, The reason I'm doing this is because as part of the demo, I'm going to get people in Vancouver to connect to my machine and send me messages. That's what's going to happen. Or like I could also write this out as localhost, but I'm going to use my own IP address. So that's advanced TCP IP, and then it's going to be this. You can just Google how to find your own local IP address, and you'll find different instructions based on the machine that you're on. So here's my IP address. And now the next thing that I'm going to see is I can't just connect to an IP address. I need to also specify what port I'm talking to. Right? On a machine, right, or on a particular IP address, there may be many programs. And I don't want to talk to all of them. I want to talk to one particular one. So every program gets to decide which port I'm going to claim as my own right now. Right? And only one program may, at any time, have access to that port. So there are many ports. You can Google this. How many ports are there? Mac OS. I don't know. How many ports are there? And we're gonna say networking instead. How many ports are there in networking? There are 65,535 ports that you can pick from. That's a lot of ports. Your machine just handles them. Are they actual physical things on your machine, like 65,000 pins? No. Right? It's a bit more of a conceptual idea, right? But they're like addresses, or they're like apartments in an apartment building, where you go up and you buzz the correct thing. So I get to pick any number I want between 1 and 65,535. Does anyone have a favorite number that's within these bounds? So you used to use port 88 at work, right? You said 88?
Yeah.
Cool. So we could say, all right, the port that I'm going to connect to is 88. Right? And that might be a good port. Right? I can test this out. What I'm going to find is that there are some ports on my machine that are already being used. Right? So for example, port 80 is already being used. 8080 also tends to be used sometimes. There's like a 5312 or so. There's like a couple different ports that might already be used. But you can always just pick a different number. Right? So we'll try out 88 and we'll see if that works. Okay. Right now, what I'm going to do is when I run this thing, it's going to try and connect to the IP address that I gave it and the port that I gave it, and just see if there's somebody listening on that side. Cool. So what I got right now is something that says con refused. Con refused might stand for connection refused, right? I don't know at the moment if there's somebody at 88 already listening who has refused my connection, or if my connection just failed because there wasn't somebody listening there. Right? So what I might try is try out a couple different numbers. Let's try 1372, right? Gonna be a pretty uncommon number maybe. And when I run this right now, I'm gonna see that it's the same error, con refused. Let me try out another one, 1337. Right? Also, con refused. So what this is telling me is that likely the connection was refused because there isn't somebody listening on the other side. So that's what I'm going to do next, is I'm going to have to make a program that waits for somebody to arrive. This is the equivalent of knocking at a house that isn't there. Just no one's there. So I'm going to create the server. Here's my server code. For server, the code is actually going to be pretty similar in terms of bringing in the net, module. So const net equals require net. Pretty much identically to how we created the client, we're going to go server equals net.create server. Pretty much exactly the same. And with the server doesn't need to connect to anyone. It doesn't really need much configuration, so it might be OK for me to even just call this empty right now. Right? Again, I encourage you to look at the documentation, and it'll tell you how you can call this function. I just know, because I've used this before, that I can call it like this. And what I'm going to find is that when I go const server and I just start it up like this. And so I'm going to have 2 terminals for this now. This is in my TCP demo. I'm going to run my server.js. And you see that no error pops up, right? Which is good, because if I had mistyped my create server function, I would get an error. I haven't mistyped it. So there isn't an error that pops up. But what am I noticing about when I run my create server function, or when I run the script? What do you see happening? What's that? It just exits out, right? It just quits. And I don't want it to quit. I want it to wait. I want it to hang, right? So what I get to do is I get to say, hey, once you've made the server, actually have the server start listening. And I want you to listen on a particular port. I want you to listen on port maybe 88. Right? And when I run this right now, what I might find is when I go node server, it just hangs. So now potentially there is somebody on port 88 just listening. Have I told it to do anything when it receives messages? No. But it's just kind of like at the window. It's just there. Right? Now what I will get to do is I get to script it up and say, OK, when you receive a message, here is what you will do with the message. Right? I'm going to be writing code like that. Now, I have also solved the problem that I had over here, which was I was running into an error because there wasn't anybody listening. Right? I'm going to notice now that when I look at, this is my server still running, right? It's still hanging. When I go back to my client, and I want it to run my client, what's my client doing? Well, it hangs as well, right? Because my client was able to successfully connect to someone. And so now that I have an actual established connection between what I'm going to call, again, a server and a client, I want to start sending messages back and forth. Now, TCP is special because it'll let the client send messages whenever it wants, and it'll also let the server send messages whenever it wants. Right? The client can send a message every 4 seconds, or the server can send a message every 4 seconds, or whatever, whenever it wants, along the line. Right? There's very few rules about how you send messages in TCP. The one rule that we're going to have is that you have to send text. Right? For us, we're going to send text. TCP is a little weird. So you can send any kind of arbitrary zeros and ones sort of back and forth to represent text. We're going to want to send text in a particular format, and it's going to be called UTF-8. So let me just write that in here. We're going to be wanting to send text that is like strings that are human readable. So I'm going to have some configuration code today, similar to what I did yesterday. And again, I'm just going to say, ignore that stuff, but just accept that it's some configuration. Okay? And if you want to, you can dive deeper into learning it, but it's not necessary right now at all. So we will be taking a look at that. Now, I want to send a message from the client to the server. And if we think back to how we had set up our imaginary code, so here's an example of our imaginary code. We'd said, when we connect, it might be better for us to rename this as something like a connection as opposed to server, but we'd said, when you connect, then send a message. We're going to see that we're going to do exactly the same thing in our TCP demo. Right? The code's just going to look slightly different in syntax. I'm going to get to say that when my client on connection, right, on connect, then run a particular function. So I might console.log I connected. Right? And what I'm going to notice here is that my server still running. I haven't edited my server. But when I restart my client, when it connects, it prints out I connected. Right? Now, I don't want to just print out I connected. I want to send a message. Right? I want to send a message from the client over to the server. So what I'm going to get to do is I'm actually going to be able to say client.write. And I'm going to be able to write to the server. I want to be upfront. I might get some syntax slightly wrong, or we might get some gibberish down the line, right, when we send the message, may or may not. And then I might have to do some configuration to make sure that the message is being sent properly. What I'm going to do is I'm going to go client.write, and I'm going to write hello world. Right? So when I run my client now, I go node client.js, and I just want you to notice that I haven't received an error. Right? I can run this as many times as I want. There's no error. Right? Meaning that this function here is being called, and in fact, I could go console.log after writing the message. And I will see that I get I connected and then after writing the message. Right? And now my job is on the server side to listen for that message. Right? Listen for connections, and then also listen for the data the connections send me. And those are going to be two steps. First, I have to listen for when people show up. Right? When do people connect? And then I get to say, OK, when the person who has connected sends me a message, then I want to do certain stuff. That's the opinion that server code is going to have. So here I am over on the server side. Right? And the code is going to look slightly similar in terms of being able to attach listeners or handlers. But the handlers are going to be slightly different themselves. I get to say something like, when the server, so server.on, and server.on is actually going to receive anytime there is a connection. So anytime there is a connection, I want to run maybe this callback. New connection. Right? So maybe the callback says, anytime there is a new connection, I just want you to print out the words new connection. And when I run this right now, so I'm going to restart my server. So there's my server running. I'm going to find that every time I run my client, node client, over on the server side, it says there has been a new connection. Right? And this is kind of wild. Like we now are listening from one program over to another. Right? Right? So I'm going to restart this again. And now when I see this, I get new connection. And honestly, this on its own is more than enough for what we need for today's lecture. So what I'm going to do from here is I'm going to speed up a little bit. I'm going to add some features and talk my way through it. Right? But I want to be very clear that the stuff that I'm doing right now is almost all of it is going to be identical to what we just did right now, which is waiting for something and attaching a callback to handle it. Right? So right now, all I did was I waited for a connection. But one of the things that I actually received through this callback, if I was to look at the docs, is I actually get the connection, or I actually get, if I wanted to rename it, client. I get access to the client. And I get to say stuff like, here's my new connection, and here is the client who connected. And if I was to restart my server, I want you to see that when I connect with my client, over on the server side, what I got was a big old mess of stuff. And in here, there is information like, what is the IP address of the person who's connected, right? If there's other information like a name or whatever, all that stuff is in there. Right? And what I'm able to do is I'm able to send messages back, or I'm able to listen specifically to that client. Right? I'm able to listen to that client to talk. So you can think of basically the server having a whole series of phones. And what I'm saying here is, when a phone rings, this is what I do with the phone. So I can pick up the phone and I can say, hey, anytime that that client sends me some new data, then maybe I want to console.log that data. And I really want to stress, do you see how I had to put this inside of the other callback? Because the way that this is going to be phrased is, when I receive a connection, right, then I get to say, when that connection sends me a message. Right? And now I already know that my connection is sending a message. It's sending hello world. And over here, this is saying, so I receive a connection, and then I listen to that connection to send me some data. We're going to see what happens here when I restart my server. So I'm not going to console log client right now, because I don't want just a big mess in there. I'm going to restart my server, and I'm going to start my client. So over on my client, I know I've sent the message. And over on my server, I might have received something. I got the word data. And that's because I wrote data as a string. Whoops. So let me not make that a string. I want to console log the data that this callback receives. So let me just restart my server real quick. That was anticlimactic. Let me restart the client. Boop. Now when I look over at the server, I get this thing here. Buffer 48, 65, 6C, 6F, whatever. Right? Some message has been sent, though. This buffer thing is let's call it a representation of like zeros and ones. And those zeros and ones could be interpreted in many different ways. Right? It's just messages coming down the string, or down the wire. But I can tell my server, you should read these messages as text, and then it'll be able to actually interpret it as text. So there is one extra line of configuration that I'm going to add in here, which is specifically up inside of here, I'm going to say, this client, set encoding, meaning let's listen or let's interpret whatever this client sends to me as UTF-8. And UTF-8 meaning text, right? It's going to mean letters and numbers that are like interpretable by humans. I'm going to notice that when I restart my server now, instead of printing out the buffer, when I connect with my client, what I actually get is hello world. And this is just madness to me. Like right here, I'm like, incredible. What? No one's ever done this. Like, I got a hello world. Just all the possibilities. Because now you can do anything. I can run arbitrary code on one machine, and I can run arbitrary code on another machine. Right? And I could, if I wanted to, in here say something like, I don't know, if data, right, because it's just text, if the data is open door, right, maybe if the message open door has been received, then I could like, maybe this computer here is connected to a motor that opens up a door, right? That could be door.open, right? And now I have two machines where I can, from one machine, control a door that's actually controlled by the other machine, right? What I'm meaning to say here is that like communication can be arbitrary. You can communicate for any purpose. And we can tell a machine to do anything. You're likely going to mostly be communicating to send data back and forth, right? And to send like web data back and forth, right? Like websites. What I'm going to do here right now is I'm going to expand this demo just a tiny little bit. I'm going to say that I want to, on the server, print out every message that I receive. So I've already done that, right? Every message that the server receives, I want to print out. The other thing that I want to do is I want my client to each send like a a random message or something, like something unique. So I'm going to whip up a little bit of like extra code just to kind of get funky. I'm going to make a const called emoji. I'm going to put like 4 emoji in here. Here's a tomato can. Here's a robot. Here is a trumpet. And we'll do one more. We'll do a little truck. Right? So I have these different emoji. And the thing that I'm going to do with the emoji is I'm going to say that I want people to send every time you press a button to like send the particular emoji. We'll work our way up to this, but we'll do this in, I don't know, maybe that might be harder than it's worth. I definitely want to have some functionality, like sort of like chat, where I'm able to, from the client, continuously send messages. Right? Maybe we'll start off with text and then we'll do the emoji afterwards. Meaning that what I'm going to have to do from here is I'm going to need to introduce the process standard in stuff. Since you saw that yesterday and you spent some time playing around with that yesterday, I think through the assignment, correct? And you will get time today to work on that. Like today is all about standard input and TCP. I'm going to make a separate demo where I'm going to sort of quickly gloss over some of that stuff. And if there's content in here that you want more explanation of, just come to me like right after the lecture, or same with Victoria, just let me know, and I'll explain things to you. But I'm going to call this one like chat demo. Right? The client and the server code right now on the chat demo are pretty much identical. So let me save stuff. So the client and the server code on the chat demo are pretty much identical to what we had in the previous TCP demo. But there's going to be the slight difference where I'm going to bring in, over on the client side, the standard in stuff. Right? So again, similar to yesterday, like this code is going to be pretty much identical to yesterday in terms of bringing in standard in. I'm going to use this thing here, standard in.resume. Standard in.resume, what it's going to let me do is it's going to let me write like lines at a time as opposed to characters at a time. Right? It's just a configuration that lets you type out a whole phrase and then press enter, as opposed to sending a character at a time. So I'm going to say standard in.resume, and then the other thing that I'm going to do is I'm going to attach a listener to standard in, right? And what this listener is going to do, and I'll just comment out all this stuff. What this listener is going to do is every time I get some data, I'm going to send that data to the server. Right? So I'm going to go, here's this data. I want to go client.write data. So almost identical to what I had before in terms of client.write. But now this data is going to come from standard input. Right? Again, I know I'm glossing over this, but you can play around with it a little bit. Right? What I'm doing here is the messages that I'm sending, I want to source from the user. And then I'm going to put in a special message in my standard in kind of check for the data. What this one says is, do you remember when we did the standard input yesterday? I couldn't quit. This is a fix for that, which says whenever somebody types \q, it quits the program. Right? So it's like a special message. So this is my handler for waiting for somebody to write some stuff. Oops. For waiting for somebody to write stuff. I'm going to take that and I'm going to, yeah, let's forget about the emoji for now because we're going to go like a couple minutes over time. I'm going to make sure that that happens after I have declared my client connection. And I haven't changed my server code. My server is exactly the same. When I go over to that chat demo and we're going to start maybe the server. So the server's running. And I'm going to go over to the chat demo and start my client. Right? It still sent that message from before, the hello world. So I can see that here. But what I also have access to is I can write, what up, bro? And press enter. And over on the server side, I will actually have received what up, bro. Right? I've actually received that. So we're going to end this lecture on 2 notes. One is that I'm going to give you the client code right now, and I want at least some of you to just run it. Right? You can save it as a JavaScript file and go node client.js. I want you to run it and see whether it does anything, and then send messages to me. Right? That's the first thing we're going to do. Then I'm going to slightly edit the code so that you get messages back. And then I'm going to give you a sentence-long snippet about what HTTP is, because it's not very important today. Sound good? So here is the chat demo, and I'm going to paste it into Slack for you. Unfortunately, Victoria, this only works on the local network. But what you can do is when I send you the, so we're at Vancouver, September 16th. So that's the code for the client. So for Victoria, I will be sending you both the client and the server code in the notes. Feel free to test it out and play around with it on your network, and you'll be able to get, if you have one machine running, a bunch of people connected to you. Yep. Question over there? No. So you should leave it like that, because you're going to be connecting to my computer. Right? So there's no need to change the IP address because it's pointing to my IP address. And what I'm going to do is I have my server running. So as you connect, you should have popping up like a message up over here. And there we go. So we're already seeing somebody connect. Okay. And once you've connected, you can write a message and press enter and see what happens. Oh, wait, let me. Oh, yeah, hello from the back of the room. Awesome. And we got a lull. Right? So we've made our own chat application here. I think this is, honestly, I think this is wild, because we haven't actually written a lot of code. We got me. But we have messages being streamed to a particular place. Right? Too fast to go. Nima, you quack me. What is love? There you go. One of the first times that I did a lecture like this, I had the machine speak out the words. But we needed quite a bit more extra code for that. So this here, we've made a chat room. Right? You're going to be working with something very, we got karaoke going on. You're going to be working with something very similar today. What you're going to be doing is you're going to be connecting clients to a server to make it play Snake. Like you're going to be controlling like a network-controlled Snake in a multiplayer game. Right? Similar to a chat room, but with just more visual kind of aspects to it. Right? And yeet. Now, I'm going to change the server code slightly, so I'm going to turn off my server. One of the things that you have in your client right now is that, oh, actually it doesn't really say that. Oh yeah, it doesn't. So I'm going to edit your client just slightly. I'm going to say that your client, whenever it receives a message, it's going to print out the message. So we're going to go data, we're going to go console.log, and I'll just go -- to show that it's a message from the server, and then the data itself. And I'm doing this just so that like you're going to be receiving the messages from the server. Right? So if you want to write these lines of code at the end of your file, then that's cool. I'll just paste them into Slack, and you can paste them at the bottom of your file. Right? And what I'm going to do over on the server side is I'm going to say that whenever I receive a message, not only do I print that message out on the server side, right, I want to send it to all the clients. I want to echo that message. And I want you to think, like, how can I get this message echoed to people? What do you think I'm going to have to do for that? Pardon? I might have to loop through the clients. That's exactly it, right? I might want to go through all the clients and to each one of them write a message. So what I'm going to do is I'm going to add some last little extra code here, and then we're not going to touch this code anymore. I'm going to make myself an array, and I'm going to call this array clients. Right? Now, with the tools that you'll be using in the future, you won't necessarily have to do this. But I'm doing this to explicitly show you that like, the clients are contained somewhere. Every time I get a new connection, what I'm going to do is I'm going to push that connection to my client's array. I'm going to push that connection to my client's array. And I can do anything I want with this client, such as I can go client.write, welcome to Nima chat. And now I'm telling the client, hey, you're on Nima chat. And then the other thing that I can do is whenever I want, just as Fabio said, is I can loop through all of my clients. I can loop through all of my clients, and I can send them messages in a loop. So I could go clients, we'll go for client of clients, and then I can go, I don't know, we'll call this individual, just because I already have the word client up here, and I don't want those to clash. For individual client of my clients, I want to each individual client write to them the message that I'm echoing. Right? Again, this code here, extra. It's way extra. Right? But I'm trying to push you to just see this here. Now, I'm realizing that one of the things that we actually do need to do over on the client side, so do also write this code in there, is client.setEncoding UTF-8. UTF-8. The reason for this is because we have the same issue from the server sending to the client, is that I want the messages that are being sent to be received as UTF-8. So I'm going to put that into the Slack as well. So what I should be able to do now is I'm on my side going to be running my server. Right? And I'm already seeing people send messages. It's your girl. So what I have here is there's too many people connecting. So let me just restart the server. Can you put up your hand if you're connecting? Cool. Okay. Well, all right. Looks like that's going pretty well. Are people receiving messages back and being printed on your screen? Excellent. Right. So now over on your end, you can send messages and also see all the messages that arrive. Right. Which I think is pretty cool. And so this here is TCP. TCP is this very, when I say basic, I'm going to use the word basic, it has very few rules on it. It's a wire, you can shout down it, and you get messages back. The important thing is that there is a host, at least, a server, and you can have many clients connecting to that server. Right? Back up, what my... All right. So in the future, when you're working with HTTP, there's going to be rules about how you send messages back and forth, but that's not going to be today's lecture. And it looks like we have crashed my my server. Yeah. Oh, no, you know what this is? This is trying to send a message to somebody who disconnected. So I don't have code that covers that. That's about as much as I want to say today. I know we went 10 minutes over. Sorry about that. Hopefully you found this helpful. Right? And you're going to be writing a lot of very similar code for your assignments today. I will send out these notes like almost immediately. Just give me like 10 minutes. I'm assuming, are there any questions that need to be addressed right now? No? And then, oh, sweet. And Alan set it up on Victoria. That's awesome. Thanks so much for doing that, Alan. That's awesome. So have a great rest of your day. Feel free to message me if you have any questions. And yeah, I think you're really going to enjoy today's assignments. Cool. Take care, everyone. Oh, I'm really sorry, Victoria. That must have been really loud. I dropped the mic. Yeah.